Hi everyone, welcome to Math 150 College Algebra. Today we will learn about Chapter 2, Function and Graphs. Section 2.1, Basic of Function and their Graphs. Now we talk about definition of relation. Relation is any set of ordered pairs. The set of all first components of the ordered pairs is called the domain of the relation. And the set of all second components is called the range of the relation. Okay, remember, domains, the first component, okay, range, the second component. Okay, just remember that one. Usually we call domain is X, range is Y. So it's like the order pair. Yeah, domain is X, range is Y. So this is easy. Okay, so now go the second one. Find the domain and the rest of the relation. Okay. The relation is the set containing the order pair 0, 9.1, 10, 6.7, 20, 10.7, 30, 13.2, 40, 21.2. Now look at, remember, domain, the first component or X. Yeah. Okay, write down over here. Make bigger first a little bit so I can see. Okay, this is the first one, X. Yeah. Okay. Now look at domain. Domain is 0, yeah, 10, 20, 30, 40. Okay. Now where's the second component or Y? Yeah. So this is Y, this is Y, this is Y, this is Y, and this is Y. Okay. 9.1, 6.7, 10.7, 13.2, 21.2. Okay, it's not hard, yeah? Just remember, domain is the first component, or X. Range is the second component, or Y. Now, definition. A function is a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds to exactly one element in the range. Remember, exactly one element. Okay, just this is from domain to range. Okay, exactly one. This is function. This is not function because not exactly one. This is function. This is not function. Okay. Now, example. Determine whether the relation is a function. Okay. One, yeah, the set containing the order pair is 1, 2, 3, 4, 6, 5, 8, 5. Okay, write down this is domain is X, yeah. Range is Y. So just put domain is 1, 3, 6, 8. Just 1, 3, 6, 8. Okay. How about range? Yeah, Y. 2, 4, 5, 5. There are 2, 5. We just need to write down one time. Okay. We don't need to duplicate. Okay. Just write down one time. So just this is 2, 4, and 5. Everybody follow? Okay. So now, so 1 to 2, 3 to 4, 6 to 5, 8 to 5. Okay, look at again. Everything's exactly one. Yeah, exactly one element to the range. Okay, this is function. Yes. Okay. Now go to the function as equation. If an equation is solved for y and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x. Example, example. Determine whether the equation defines y as a function of x. Okay, x squared plus y squared equal 1. Okay, remember, try to put y equal. Okay, so now move x squared to the right side become negative because positive move become negative. So y squared equal 1 minus x squared. So both sides square root both sides because we need y. Yeah, so become this is square become cancel with this one. So become y equal plus minus square root 1 minus x squared. Okay, the positive negative show that for certain value of x, there are two value of y. For this reason, the equation does not define y as a function of x. Try. Okay, I just put try change the x. Okay, like put 1 minus change x become 2. Okay, change x equal 2. So just put over here. Yeah, this is 2 squared. So answer become plus minus square root 1 minus 4. The answer is plus minus square root negative 3. So they are two answers. Yeah, the first is x equal to y is plus square root negative 3 negative square root negative 3. Not exactly one element. Okay, this is not a function. You follow, yeah? So now, go to the next one. Function notation. The special notation f of x read f of x or f at x represents the value of the function at the number x. Example, if f of x equal x squared minus 2x plus 7, evaluates f of negative 5. Okay, the question is f of x equal x squared minus 2x plus 7. Just replace x with negative 5. Okay, so now change negative 5 squared minus 2 times negative 5 plus 7. Negative 5 times negative 5 is 25. Negative 2 times negative 5 is plus 10 plus 7. So the answer is 42. Thus, f of negative 5 equal 42. Now, graph of a function. The graph of a function is the graph of its order pairs. Example, graph the function f of x equal to x and g of x equal to x minus 3 in the same rectangular coordinate system. Select integers for x starting with negative 2 and ending with 2. For x, you can put any number. You can put from negative 3 to 3. You can put negative 5 to 5, or we can put negative 1 to 1. It's up to you. Okay? But for this problem, starting with negative 2 and ending with 2. So now, f of x equal to x. Okay? The x is negative 2, negative 1, 0, 1, and 2. So after we replace x with negative 2, yeah, I just put over here, yeah, 2 times negative 2. Okay, the answer is negative 4. Change now. 2 times negative 1, so the answer is negative 2. 2 times 0, the answer is 0. 2 times 1, the answer is 2. 2 times 2, the answer is 4. Okay, so the coordinate is negative 2, negative 4, negative 1, negative 2, 0, 0, 1, 2, 2, and 4. So look at negative 2, negative 4. Negative 2, negative 4. Here we go. Yeah. So now again, negative 1, negative 2. Negative 1, negative 2. Over here. Okay. 0, 0. Okay. Next, 1 and 2. Next one, 2 and 4. Okay, we got this one. So this is f of x. The red one is f of x. Okay. Now look at g of x equal to x minus 3. Okay. Just replace x with negative 2. Okay. So this is 2 times negative 2 minus 3. 2 times negative 2 is negative 4 minus 3. The answer is negative 7. 2 times negative 1 minus 3. So 2 times negative 1 is negative 2 minus 3 is negative 5. 2 times 0 minus 3. The answer is negative 3. 2 times negative 1 minus 3. 2 times 1, okay, minus 3. The answer is negative 1. After that, 2 times 2 minus 3. The answer is 4 minus 3 is 1. Okay. After that, just look at the point, yeah. Negative 2, negative 3. Negative 2, negative 3. Yeah. Negative 2, negative 3 over here, yeah. Then negative 2, negative 7. Sorry, negative 2, negative 7 on the bottom. Yeah. So now what next? Negative 1, negative 5. Yeah. Negative 1, negative 5. After that, 0, negative 3. 1, negative 1, 2 to 1. Okay, the blue one is g of x. So you can see, yeah. So 2x and minus 3. This is f of x is equal to x. G of x is 2x minus 3. Okay. Now, if you see this one is, yeah, it looks parallel. It's right. And looks parallel, yeah, it's parallel and going down by 3 because 1, 2, 3. Because it's a negative 3 is, yeah, is because minus 3, so it means going down by 3. Okay, it's the same, yeah. F of x equal to x, g of x is to x minus 3. Parallel, but is shifted down by 3. Yeah. Okay, now go to the next one. Now about vertical lines test for function. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. Example, use the vertical line test to identify graphs in which y is a function of x. Okay, look at again, the blue one is the vertical lines. After that, look at the intersection over here. Okay, look at again, if more than one point, it means it's not a function. Okay, definition. Remember, if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. There are 2 points over here. So this is a function. It's not. This is not a function. Okay. But again, look at the next one. Okay. Look at vertical lines. So how many points? Only 1 point over there. So because only 1 point, this is a function? Yes. Okay. Remember about vertical lines. Okay. It's vertical lines test is more easy to look at this is function or not. Okay. Now go to the example. Use the graph to find f of 5. Okay. So look at again here. What's the meaning? F of 5 is mean f of 5. Yeah, you have to find. So it means this is f of x. So x equal 5. Yeah. So look at f if x equal 5. This is x equal 5. Okay. So what next? Just go up. Yeah. Go look at x equal 5. Go up over here. Going the up over here. Here we go. Now look at the y. Okay. Okay. So the y is f of 5 equal 400. Okay. So now the next one. For what value of x is f of x equal 100? Okay, so this one is y equal 100. Look at y equal 100 over here. Yeah, this is 100. Okay, so just go find. Here we go. So x equal 9. So f of 9 equal 100. They asked about x equal 9. So we got the answer. Okay. Now, identifying domain and range from a function's graph. To find the domain of a function from its graph, look for all the inputs on the x-axis. Okay, remember, domain is x. Just put x-axis. Okay, so look for all the inputs on the x-axis that corresponds to points on the graph. To find the range of a function from its graph, look for all the outputs on the y-axis that correspond to points on the graph. Okay, domain is x. Just remember that one. Range is y. Okay. Now, example. Use the graph of the function to identify its domains and its range. Remember, domain is x. Just focus with x. Okay, just focus with x. Okay, this is I just change the color, yeah, become red for x. Look at this one, x, everything x. Okay, domain from this, look at the x from -2 to where? Just put, just make a line like this. Just make a line like this. Oh, domain is from -2 to 1. Okay, this is include because dark, yeah. The point is dark, full. Okay, it mean include, close. So we can write down domains. So the set of all real numbers x such that -2 less than or equal to x less than or equal to 1. Or we can write down with interval notation because this is close. This is close. Use bracket. Okay. So bracket -2 to 1 close bracket. Okay. Now range. Range is y. Okay. Range is y. Clear first to make sure. Okay. So now I use blue. Okay, for y. Look at y. This is from here and from that. Okay. Just remember for domain, just look at the x. Just look at left from left to the right. Okay. For range, yeah, because y-axis, just look at from the bottom to the top. Okay, bottom to the top. Okay, so bottom is 0 to 3. So we can write that the set of all real number y such that 0 less than or equal y less than or equal 3. Or we can write down with interval notation. Yeah. So bracket 0, 3. Remember, close, use bracket. Open, use parentheses. Okay. Now, the next one. Use the graph of the function to identify its domain and its range. Okay, remember, domain is X. Look at X. From this one, look at X to this one. Okay, from -2 to 1. But this is open. Okay, so we write down the set of all real number X such that -2 less than X less than or equal 1, because this is closed. Okay, because this is the first one is open, the second one closed. So we can write down with interval notation. Here, because open, use the parenthesis -2, 1 bracket. Okay, this for the domain. Remember, always from left to the right. Yeah, from left to the right. Okay, now look at Y. I use blue one for Y. Range. Look at Y. Yeah, remember from bottom to the top. Okay, so now -1 to 2. Okay, -1 and 2. 2 is open because this is open. This is closed. Okay, so from -1 to 2. Okay, we will follow this one. Okay, now go to the next one. Identifying x-intercept from a function graph. To find the x-intercepts, look for the point at which the graph crosses the x-axis. Okay, x-intercept cross the x-axis. Okay, to find the y-intercepts, look for the point at which the graph crosses the y-axis. A function can have more than one x-intercept, but at most one y-intercept. Okay, usually for the x, yeah, the x is more than one, yeah, but for y is most one, only one, yeah, most one y-intercept. Okay, again, identify the x and y-intercept for the graph of f of x. Look at over there, yeah. The red one is x, yeah, you can see, yeah. So the x-intercept, yeah, look at, crosses the x-axis. Yeah, so the x-intercept are -3, 0, yeah. The point, yeah, -1, 0, and 2, 0. Okay. And the y-intercept is, look at the y-axis. Okay. 0, -3. Okay. That's all. I think we're gonna continue to example for the next video. Okay. Bye-bye.